Okay, section 7.4 is on using substitution to solve a system of linear equations. So far we've identified what a linear system is, and we've learned how to solve a linear system using graphing methods, but as you could see in section 7.2, that could be time consuming, and sometimes you'll get a graph that's difficult to read the exact point of intersection, especially if you're doing it by hand. Now, if you're using technology like in section 7.3, it's a little bit easier, but not always. You don't always have technology on hand to graph, and there are other ways you can solve a system just with pencil and paper. And one of these methods is using substitution, and these are algebraic methods, substitution, and another method we're going to learn is elimination. But right now we're going to concentrate on substitution. And the method of substitution is basically, as the word suggests, it involves substituting or making a substitution from one equation into the other. So we'll just start off with the first example, and it's 2x plus 3y equals 13, and negative 4x plus y equals negative 5. So the first step is basically to decide which equation you're going to rewrite so that you get one of the variables by itself. So either, in this case, we've got x and y, so try to rewrite the equation to get x by itself, or rewrite the equation to get y by itself. And if you look at both equations that are there, the second equation is the one that's a little bit easier to get the variable by itself. So I'm going to take the second equation, negative 4x plus y equals negative 5, and I'm going to rewrite that so that y is by itself. So basically I have to take that negative 4x and add 4x to both sides of the equation, or bring the 4x over, whatever way you want to look at that. So I end up with y equals 4x minus 5. So that's what we call our star equation, or what I call a star equation. So then you're going to take that star equation, and that came from equation 2. So you're going to take that star equation and you're going to substitute for y in the first equation. So because we've identified what y is in terms of x, so we're going to take the first equation, 2x plus 3. Instead of y, we're going to put in that expression, 4x minus 5. So basically it's the same equation 1, except instead of y now, this y right here, we have replaced it with 4x minus 5. So then the next step is to simplify that resulting equation. And if we simplify, we're going to get 2x plus this 3 is going to be distributed to both parts inside, so that would be plus 12x minus 15 equals 13. And that's going to give you 14x minus 15 equals 13. So you see you have a single linear equation with one variable in it. So usually you would solve a linear equation like that by isolating the term containing the variable, bringing all the constants to the other side. So that negative 15, if you add 15 to both sides, you would end up with 13 plus 15 on the right hand side of the equation, and just the 14x on the left side, and that gives you 14x equals 28. And then to get x by itself, you just simply divide both sides by the number in front of x, which in this case is 14. So you end up with x is 2. So now we have one of the variables, the values of the variables that we're looking for. So the advantage basically to using the substitution method is by making a substitution, we have one equation with one unknown. So we were able to solve and get x equals 2. And then once you get that value, you go back, and the easiest thing to sub back into would be the one that we rewrote. Now you could sub it back into one of the original ones if you want, but if you've rewritten your equation properly, the star equation would be easiest to plug into because it already has the y by itself. So that would be 4 times x, in this case x is 2, so 4 times 2 minus 5, and that will give you 8 minus 5, or y equals 3, and that's your y coordinate. And you can always go back and check your answer in the original system by plugging those values back in for x and y in your original equations. So if I take x is 2, we said, and y was 3, so if we go back into this one, we have x is 2, and y is 3, and we get 4 plus 9, which is 13, so that's a true equation. So then if we check it in the second equation, we have negative 4 times 2 was the x value, plus the y value is 3, and that gives you negative 8 plus 3, which is negative 5, which is the right side of the equation. So you know that you've got the correct answer because it works in both equations, so therefore it's the solution to the system. Okay, so we'll try another example. So we've got two equations here, and if you look at these two equations and you try to decide which variable you're going to rewrite, if we take a look at the first equation, if we try to get x by itself, we're eventually going to have to divide everything by that 4 that's in front of the x to get x by itself. And that's going to give us some fractions when we, particularly for the y term, because 2 divided by 4 is going to leave you with a half. So I'd probably avoid changing the first equation to get the x by itself. But if we try to rewrite the first equation to get the y by itself, we'll eventually have to divide everything by that 2 that's in front of the y. So that means that we just take a quick glance at the other numbers that are there, the 4 and the 8, they divide nicely by 2, so you can avoid fractions. So I would pick that first equation. If I was picking that first equation to rewrite, I would rewrite for y. If we just glance ahead to the second equation, again, kind of using the same idea that we talked about for the first equation, if you have to get x by itself, you're going to have to divide everything by negative 2 eventually, because that negative 2 is in front of x. And looking at the other numbers that are there in that equation, 3 and 20, 3 doesn't divide nicely by 2, you will get a fraction. So again, I'd probably avoid writing the x by itself. And similarly with the y by itself, you're going to eventually have to divide by 3, and that'll give you fractions as well in front of the x, and 20 over 3 doesn't work out nice. So the best one out of all our choices would be to rewrite for y in the first equation. So 2y equals, and we bring the 4x over to the other side, be negative 4x plus 8. That would be our first equation being rewritten. And then we're going to divide everything by 2. So that gives you y equals negative 2x plus 4. So we have our star equation. So then we're going to substitute our star into the equation that we didn't rewrite, which would be equation 2. And we're going to replace the y in the second equation. So that would be negative 2x plus 3 instead of y, we're going to just put brackets there for now, equals 20. So then 3 times the y value is going to be replaced with our star equation, which is negative 2x plus 4. And then we're going to simplify negative 2x plus, going to distribute that 3. So that's going to be plus a negative, so I can just say minus 6x, and 3 times 4 is 12. Excuse me. So this would be equal to 20. So then we've got negative 8x plus 12 equals 20. Excuse me. So negative 8x equals 20, take away 12, because you're isolating your term containing the variable. So negative 8x equals 8. And that gives you, divide both sides by negative 8, so that gives you x equals negative 1. And then you go back and sub x equals negative 1, substitute x equals negative 1 into your star equation again to get your y. So our star says that y equals negative 2x plus 4, and we just found that x was negative 1. So that gives you 2 plus 4 is 6, so y equals 6. And again, you can just go back and plug in. We don't have a whole lot of room to write, but we can just plug it and do it in our head. If I plug a negative 1 into the first equation, I get 4 times the negative 1 is negative 4. And then 2 times 6 is 12. Negative 4 plus 12 is 8, so it does work in the first equation. And then if I plug the negative 1 in for x in the second equation, I get negative 2 times a negative 1 would be positive 2. Plus 3 times 6 is 18, so 2 plus 18 is 20, so it works in the second equation. So I know my answer is correct because it works in both equations, which means it will be a solution to the system. There's a couple more questions here to try, examples to try. The first one, if we look to see which one is the easiest equation to rewrite, it would be the first one, because it would be easy to write m by itself. So we're going to take that first equation and get the m by itself, so that would be m equals, and then bring the negative 3n to the other side, and 3n to the other side would become a negative 3n plus 2. And this would be our star equation. So then we substitute our star into, call this equation 1, this equation 2. So if the star equation came from equation 1, so we'd substitute it into equation 2. So instead of m, we're going to have, instead of 2m plus 3n, we're going to have 2 with brackets where the m would usually go, because we're going to replace that with negative 3n plus 2. And then distribute to get negative 6n plus 4. So distribute that too. And then you still got your plus 3n equals 13. You put like terms together. So the negative 6n and the 3n would be negative 3n. Plus your 4 equals 13. So then negative 3n equals 13. Take away 4 from both sides. So that will give you 13 minus 4 on the right hand side. And then negative 3n is 9. And then if we divide both sides by negative 3, you get n equals, it doesn't look much like a 3, does it? N equals positive 9 over negative 3, which is negative 3. And then we go back to our star equation. We know that m is negative 3 times n plus 2. We just found n to be negative 3. You plug that in, you get 9 plus 2, which is 11. So m is 11, and n is negative 3. And you can go back and quickly plug in to both equations. If m is 11 and n is negative 3, the first equation will give you 11 plus 3 times negative 3 is 11 minus 9, which is 2, so it works in the first equation. And the second equation, 2 times 11 is 22, plus 3 times the negative 3 is 22 minus 9, which is 13. So we know we've got the right solution because it works in both equations. The next example, it would probably be easier to rewrite the second equation for x, because you can easily get x by itself by bringing over that negative 4y. You add 4y to both sides, so that will give you positive 4y plus 3 on the right hand side of the equation. And if we substitute that, substitute our star into equation 1 this time, because the star equation came from rewriting equation 2. And we plug it in, we get 3 brackets instead of x, just replacing that x with our expression there, our star. So 2y equals 3. So we would just plug in the 4y plus 3 instead of the x, distribute and get 12y plus 9 plus 2y is 2, and that's going to give you 14y plus 9 is 2, and that's going to give you 14y is 2, take away 9. 14y is -7. And then you're going to divide both sides by 14, which is going to give you a y value of -1/2. And then our x value, running out of space, we go back into our star equation. X equals 4 times a -1/2 plus 3, which is going to give you -2 plus 3, or 1. So we've got x equals 1 and y equals -1/2. And if you go back and plug those into the equation, at the beginning 3 times 1 would be 3, plus 2 times -1/2 is -1, so 3 plus a negative 1 is 2. And then if you plug 1 into the bottom equation 2, you get 1. Minus 4 times -1/2 is going to be -4 times the -1/2 is going to be +2. So that's going to be 1 plus 2, which is 3, so it does work. Okay, so example 2, question number 2, gives you 2 more linear systems to solve using the substitution method. So in the first one, in A, we have to decide which variable, x or y, we're going to rewrite to get by itself. And if we look at the equations and see what's in front of the x's and the y's, which one would be when I divide out by the rest of the equation by that number to get x or y by itself, everything should divide nicely by that number that's in front of x or y. So using that as our kind of guide, the easiest one to rewrite would be equation number 2. Call this equation 1 and this equation 2. And it would be easier to rewrite for y because there's a -2 in front of the y. And when I bring over the 4x to the other side, it becomes -4x minus the 20 that's already there. So then I can divide easily. Everything divides nicely by -2, the number that's in front of y. So I get y equals 2x, -4 divided by -2 is +2, and then you still have x, plus -20 divided by -2 is 10. So that would be our star equation. So we're going to sub the star into the equation it didn't come from, so that would be equation 1. And that would be 3x plus, equation 1 has 5y, but we don't want y anymore, so we're going to put brackets instead of y, equals 11. And all we're going to do now is take the 2x plus 10 and put that in for y. So then if we simplify that, we get 3x plus the 5 has to distribute, so it's going to be 10x plus 5 times 10 is 50 equals 11. So that's going to be 13x plus 50 equals 11. So now we have a linear equation with one variable, and to solve that we're going to keep the x's on one side and bring the constants over to the other. So that'll give us 13x equals -39, 11 take away 50, and then we're going to divide both sides by 13 to get the x by itself. So there's our value for x, and the easiest thing to do if we want to find y is to go back to our star equation, which was y equals 2x plus 10, and we would just substitute in now -3 for x, so that's 2 times a -3 plus 10, which would give you -6 plus 10, or y equals 4. And if you go back and check quickly to the first equation, plug in the -3 for x and 4 for y, we're going to get 3 times a -3 is -9, plus 5 times 4 is 20, so -9 plus 20 is 11, so it works in the first equation. And then if we check in the second equation, 4 times a -3 is -12, minus 2 times 4 is -8, so -12 minus 8 is -20, so we know we've got the right answer. So the next example has equations with a and b in them, and if we look at the numbers that are in front of those variables, I think the first equation would be the easiest to rewrite for b, because everything divides nicely by 2. So if we get 2b by itself, we get 2b equals, subtract 4a from both sides, so you got negative 4a on the other side minus 2. And the next step would be normally to divide both sides by 2. And that would give you b equals negative 2a minus 1. And that would be our star equation. So if we go to the next equation, we would sub that into the next equation. So we have sub our star into equation 2. Yes, 2. This would be equation 1. This would be 2. So 3a plus, now just notice that this here is 2b, and we already had 2b up here. So if we want, we can actually go back and sub that in instead of 2b. Or we could go 2 times that, but you'll eventually get negative 4a minus 2. So that might be something a little quicker. We didn't even need to do those other steps to get the star equation. So we've got 3a plus, we replace the 2b with negative 4a minus 2, because that's what 2b equals. And then we have that equal to 1. That looks there. So now we've got 3a minus 4a minus 2, because I don't really need those brackets anymore. So that's going to be minus a minus 2 equals 1. And then negative a equals 1 plus 2, which means negative a is 3. And then if I divide both sides by negative 1, I get a equals negative 3. And if I go back to my star equation, I've got b equals negative 2a. Running out of a little bit of room there, so I'll move that down a little bit. So if I go back to star equation, b equals negative 2a is negative 3 minus 1, so that becomes 6 minus 1, which is 5. So we've got a equals negative 3 and b equals 5. And if we go back to our equation and plug negative 3 in for a and b for b in with a 5, we can check that 4 times negative a, and 4 times a, sorry, is negative 12, plus 2 times b is 10. So negative 12 plus 10 is in fact negative 2, so it works in the first equation. And then if we check it in the second equation, 3 times a is 3 times the negative 3, which is negative 9, plus 2 times b is 2 times 5, which is 10, so negative 9 plus 10 is 1, so it works in the second equation. So we know that our answer is correct. Alright, so the next example has some equations that aren't that nice looking. They have a lot of fractions, so what you can do first to make it a little bit easier when you're solving a system is to get rid of the fractions by multiplying both sides of the equation by the same number. And you would want to choose a number that the denominators of the fractions can divide into, so that you'll get rid of the fractions. So that would be a common multiple of the denominators. So in the first equation we have 2 and 3 as our denominators. So we would want a common multiple of 2 and 3, which would be 6. So if I multiply the top equation by 6, we will get an equivalent equation. 6 times a half x plus 6, or minus, sorry, 6 times a third y equals 6 times 3. So we've multiplied everything on both sides by 6. That's going to give us 3x minus 2y equals 18. So that's our new equation 1. And then the bottom equation, second equation, that's given to us has only one fraction with a denominator of 2, so we multiply everything by 2 to get rid of that. We would end up with 2 times x minus 2 times a half y equals 2 times 5. So that would be 2x minus y equals 10. So these are our new equations that we're going to work with. Now you don't have to do this, but a lot of people like working with whole numbers rather than fractions and for the coefficients. So if we rewrite, we're going to solve this system, 3x minus 2y equals 18, and 2x minus y equals 10, which is an equivalent system. It just looks a little different, the equations look a little different, but they should have the same solution because we just basically are working with equivalent equations to the ones that we were given. So looking at what we have here now, I would rewrite the bottom equation for y. So we've got negative y equals 2x, bring that over to the other side, it's going to be negative 2x plus 10, and then if I divide everything by negative 1, I'm going to get y equals positive 2x minus 10. So that would be my star equation. And if I sub that into equation, this we'll call this our new equation. This is our equivalent equation 1, this is our equivalent equation 2. We sub that in, I'll just put a little mark after it so it is different. So put that into, it came from equation 1, so we have to put it into 2. That would be 3x minus 2 times, again we're substituting for y, so 2x minus 10 instead of the y, equals 18. And then if we simplify that a little bit, we're going to get 3x minus, distribute that 2, so it's going to be minus 4x plus negative 2 times negative 10 is positive 20, equals 18. So that would be negative x plus 20 equals 18. So negative x equals 18, take away 20, and negative x is negative 2. If we divide both sides by negative 1, you get x is positive 2. And then if we take our star equation, y was equal to 2x minus 10, and we fill in our x value of 2, we get 4 minus 10, which means y is negative 6. So if we check in the original equations, a half times 2 would be 1, minus a third times negative 6 would be a positive 6 over 3, which would be 2. So we'd have 1 plus 2 equals 3, it works in the first equation. And then if we substitute it into the second equation, x is 2, the original second equation. So x would be 2 minus a half of 6, and negative 6 would be plus 3. So 2 plus 3 is 5. So the solution that we obtained algebraically, 2 and negative 6, 2 for x and negative 6 for y, works. Alright, the next example is a word problem in which you have to create a linear system to model the situation and then solve the system to get your answer. So the description is Alexia invested $1,800, part at an annual interest rate of 3.5% and the rest at an annual interest rate of 4.5%. After 1 year, the total interest was $73. Create a linear system to model the situation and then solve your system to determine how much money Alexia invested at each rate. And important to remember to state what your variables in your equation represent. So if we look at the information again, it's talking about two different amounts of money at two different interest rates. So if we let A equal the amount invested at rate 3.5% and B equal the amount invested at 4.5%. Then our two equations involving those variables would be that A plus B, the two amounts invested were $1,800, added up to $800, and the second one would be that the 3.5% of the first amount plus the 4.5% of the second amount give you interest of $73. So if these represent our linear system for this information, and we're going to use substitution, I would rewrite the first equation for A or B. It would be pretty easy to do either one. So if I choose A would equal negative B plus 1,800. So then I'm going to substitute my star into the equation it didn't come from, which would be equation 2, and I'm going to substitute it for A. So that would give us, with a new equation 2 of 0.035, instead of A I'm going to put in brackets, write the rest of the equation down exactly as it is, and then I'm going to put in, instead of A we said we were going to put in our star equation, negative B plus 1,800. So if we simplify that, that's going to give us negative 0.035B plus 3.5% of 1,800. So that's going to be 0.035 times 1,800 is 63. And then we still got the 0.05. B equals 73. Just come up here. So if we simplify that, 0.045 minus 0.035, we know that that's going to be 0.01. B plus 63 equals 73. And then if we isolate the B term, we're going to get 73 take away 63, and that gives us 0.01B equals 10. So then if we want to get the B by itself, we need to divide both sides by 0.01, which will give us 10 divided by 0.01 would be 1,000. And if B is 1,000, then we can go back to our star equation, that A equals negative B plus 1,800. So that would be negative 1,000 plus 1,800, which gives you A equal to 800. So it looks like Alexia invested $800 into the account that paid an annual interest rate of 3.5%, and she invested $1,000 in the account that earned an interest rate of 4.5%. And if you go back and check into your equations, A plus B, 18 is equal to 1,800, you will get that 800 plus 1,000 is equal to 1,800. And if you check 3.5% of 800 is $28, and 4.5% of 1,000 is $45, and 28 plus 45 does add up to 73. So you know you got the correct answer. So there's another example to try now with a word problem that you have to come up with a system. And it says on a school trip, the cost for lift tickets was the cost for lift tickets for one teacher and 18 students was $390. The cost for three teachers and 25 students was $590. determine the individual cost of teacher and student lift tickets. So it asks you to determine the individual cost of teacher and student lift tickets. So we're going to let T be the cost, that's what we're looking for, of the teacher lift ticket. And I'm going to use P for pupil because S, sometimes people think the S is a 5 and it gets confusing, so I'm going to use P equal the cost of student lift ticket. So we have to come up with two equations now because we have two unknowns. So you know that the one teacher ticket plus the 18 student tickets cost $390. So that would be one equation. And then 3 teacher tickets plus 25 student tickets cost $590. So those would be your two equations, equation 1 and equation 2. And looking at the equations, the first one is easy to get T by itself by just bringing over that 18p, negative 18p on the other side, and then 390. So that would be our star equation. So then we would substitute the star into the equation 2, because that's the equation that it didn't come from, and we're going to replace T. So 3 outside of instead of T, I'm just going to put brackets there because I want to put in that expression from the star equation now in a minute. So that would be negative 18p goes in there, plus 390. And then we have to simplify. We've gotten rid of the two variables and cut an equation out with just one variable, but we have to distribute. So 3 18ths is going to be negative 18ths is going to be negative 54p, plus 3 times 390 is 1,170, plus your 25p equals $590. And then negative 54 plus the 25 is going to be negative 29p equals 590 minus 1170, because we want to isolate the p term on one side and constants on the other. And when we subtract those two, we get negative 29p equals negative 580. So if we divide both sides now by negative 29 to get the p by itself, we get p equals 20. Negative over negative gives you a positive. So that will be p is 20, and then t, if we go back to our star equation, t is just negative 18 times 20 is the p value, plus 390, and that would be negative 360 plus 390, which would give you 30 teacher tickets and 20 student tickets. So if we go back and check to see if they do work in our original equations, we have that t, which is 30, plus 18 times p, which is 20, so 18 times 20 is 360, and that does give you 390. So our first equation works, and then we plug in for the second equation. 3 times the t was 30, plus 25 times the p was 20. That's going to give you 90 plus 500, which does give you 590. So you know that you got the right equation. For 30 teacher lift tickets sold, and no, sorry, that 30 was the cost, wasn't it? So $30 was the price of a teacher lift ticket, and $20 was the price of a student lift ticket. So there's some questions there now in the bottom, listed on the bottom of pages 425 and to 427 of your textbook that you can try to practice this material.